As with any fueling station, hydrogen stations have multiple safety systems in place and are built in compliance with existing codes. One such requirement is the use of emergency shutoff devices, or ESDs, which are in easily accessible locations. In a multi-fuel station, the ESDs for the hydrogen system are separate from those used for gasoline or diesel. Some stations may have a master ESD that shuts down all dispensers, regardless of fuel type. If sensors detect hydrogen levels around 50% of the LFL, or 2% hydrogen in air, when thermal cameras detect a hydrogen flame, or when a dispenser is hit or knocked down, an automatic shutdown can be triggered. In areas of the country prone to earthquakes, seismic safety is likely to be required. Stations also have electronic monitoring systems that detect other potential issues, such as an equipment failure. In each of these cases, the appropriate resources are automatically notified. This can range from a service technician to a fire department response. Additionally, due to the storage pressures involved, the cylinders require pressure relief systems, including burst discs, pressure relief devices, and safety vents. As with a vehicle, the primary safety feature on composite cylinders is the TPRD. Each cylinder has its own, which is designed to release all of the contained hydrogen in a fire situation before the composite materials that make up the outer layer of the cylinder lose structural integrity. Steel cylinders, on the other hand, don't burn, so they typically use reseatable pressure relief devices, which are PRDs that reset themselves once a safe pressure has been reached. Rupture discs may be installed as well. Liquid storage tanks use reseatable PRDs to protect against the pressure generated should the liquid hydrogen warm and revert back to a gas. This can happen if the liquid is not used quickly enough. Rupture discs are used as a secondary safety device in the event the primary system is unable to maintain a safe pressure. This could occur if the vacuum space between the inner and outer tank is lost, especially in the event of an engulfing fire. Some hydrogen releases are normal operational events, such as gas venting from the vent stack after a fueling, or venting during a liquid hydrogen tank refill. Hydrogen gas can be vented safely into the atmosphere. It is non-toxic, and in most circumstances will rise, dissipating quickly. There are also inherent safety features for the dispensing of hydrogen. This is a closed-loop process in which the vehicle communicates with the station. When the nozzle locks onto the vehicle, an initial leak check is performed. If the nozzle isn't properly connected, fueling will not start. The station periodically performs leak checks during the fueling process. If needed, the vehicle can abort the fueling. If there are any interruptions with communications from the vehicle to the station is programmed to fill the vehicle at a reduced rate and pressure. Additionally, dispensing hoses include a breakaway connection, similar to gasoline and other fuels.